Hi, this is Dan Sullivan, and I'm here with the great technology, my personal great technology scout and explorer and map maker, Peter Diamandis, and this is the next episode of Exponential Wisdom. And Peter, I'm going to go back right to your childhood passion, and it was space. And I got hooked on it with the Douglas skyrocket in the early 1950s when they started using rocket technology to break the sound barrier. But yours goes back very, very early that you got fascinated. You were born in the same year that Kennedy launched the moonshot, the original moonshot. So I've noticed in the last 2 or 3 months there's been a flurry of new developments on the space exploration, and especially on the private space exploration.
Yeah.
So fill us in.
Yeah, sure. So my passion in space got started during the tail end of Apollo and the unveiling of what I like to call that scientific documentary, Star Trek, that showed us where the world was going. The 21, 22 companies I've been involved with, at least half have been in the space business, and very proud of that. And the last few months and last few years in the headlines is not Boeing or Lockheed Martin or Airbus. It is principally Elon Musk and Jeff Bezos. I've had the pleasure to know Jeff since college. I had started a national space organization called SEDS, Students for Exploration and Development of Space, SEDS, when I was at MIT as an undergrad. And Jeff started the Princeton chapter at Princeton when he was an undergrad. So we interacted during that period. And then I met Elon back in 2000, just before he'd started SpaceX. So I got a chance to know both of these guys, incredibly what they've done. I remember back in 1999, 2000, I went and had breakfast with Jeff in Seattle, and I was like, so Jeff, what are you doing with this Amazon thing? And I said, I thought you were fascinated about space. Where'd you go wrong? And he said, well, listen, my intention is I'm going to make a lot of money on Amazon and then go spend it in space. An easy 1-2 punch plan. And in fact, he's done that, right? I mean, Jeff is now worth $150+ billion, and he's committed $1 billion a year to opening up space. Elon, who as a serial entrepreneur back in roughly 2000, 2001, sold PayPal to eBay. He netted about $180 million, I think is the number he told me last time. And he committed effectively all of that money to SpaceX and Tesla. He has revolutionized, just completely blown away the entire aerospace industry with what he's able to do. Every time he sets a new objective, whether it was, Falcon 9, then Falcon 9 reusability, then Falcon Heavy, and then Starship, and now his constellation of 12,000 satellites he's going to be launching called Starlink. He 10x's the world over and over again, which is crazy. And so our future in space, which I think is, right now, I think the next couple of decades, the time at which as a human species we move out irreversibly into the cosmos, is unlikely to be something that is going to happen on its own or by virtue of governments or large corporations. It's going to happen because these two guys, Elon Musk and Jeff Bezos, are in a fun co-opetition, or, it's the new space race. It's no longer the US versus Soviets. It's these two guys setting out their vision, which has got some similarities, but they're going ultimately in two different directions. Mm-hmm. We could talk about that if you want.
Let's start with Jeff, because I remember the day that you told me, you mean this crunching of the marketplace that he's doing with Amazon is just so that he can walk on Mars or just walk on the moon? And I said, wow, yeah, I guess that was similar to your response. What's this Amazon thing? But the thing is that the original space plan was created out of the extraction industry. So government is in the extraction industry. They need more money, they extract it.
Yes, from you and me.
He's got to earn it. He's got to earn the money to actually do this. So it puts a different dynamic on it. To a certain extent, there has to be a business model to it. I mean, government will tag along if it sees a solution that's not going to produce bad news in the headlines. But just for my purposes, and I think all of our entrepreneurs, if there's a God in the entrepreneurial heaven, the name of that God is cash flow. In cash flow, what is the vision meets viability, because that's really the key here. So what's the connector as far as you can interpret from both of the pioneers?
Well, I'll give you the plan. So let me start with Elon because it's a lot more clear. So when Elon got excited about space, after college, during the tail end of PayPal, when he sold it to eBay, his first goal was, can I embarrass NASA or can I incentivize NASA to get people to Mars sooner? And he set out a project, and I write about this in bold, where he wanted to put a mouse into orbit on Mars privately, or land a greenhouse on Martian surface privately, as a means to say, hey, listen, if I can do it as a private individual, clearly NASA should be able to do it faster and farther. And when he went to go and look at buying rockets, he went to Russia and found that the rockets being sold to him were like 50-year-old designs from the Soviet military industrial complex. And there's got to be a better way to do this. So he sets out and hires a bunch of engineers, knows nothing about the space business, just fundamentally from a first principle thinker, engineer, very smart, learns what he needs to learn, and ends up building the Falcon series of launch vehicles. And his first business plan is, I'm going to deliver space hardware payloads and eventually people to orbit 10 times cheaper than the current systems. And so he ends up building his Falcon series of vehicles, ends up making the Falcon 9 first stage reusable, which had been thought nearly impossible by the government contractors in the past. But he effectively, successfully reduces the price of getting to orbit an order of magnitude. And his business plan, early days, is selling launches to NASA and the Defense Department. There's a lot to go into here. I won't go into it. But his mission to take humans to Mars, and that's Elon's long-term goal, is to make humanity a multi-planetary species where we're alive and operating on multiple planets. So we sort of take all of the eggs out of the basket called Earth, so that if there's ever a disaster here, asteroid impact, killer virus, nuclear war, whatever it is, it doesn't destroy all of humanity. But, getting to Mars, while one could look at it as the world's biggest real estate play, how much is it worth? But you have to get people there back and forth cheaply. So he needed to create the ability, and his prediction was that he would sell a round-trip ticket to Mars for $500,000. And, well, at $500,000, I bet you there are millions of people who would be open to that journey.
Well, and they have the $500,000 to spend.
Yeah. And then, can you build the Mars base and sell Mars real estate? And, a lot of countries got started, including the one I'm sitting in right here. Both the United States and the United States of California got started by virtue of new transportation mechanisms opening up new frontiers. Mm-hmm. Elon's latest business plan just got launched in May of 2019 is Starlink. His goal is, could he use his launch capacity and his engineering prowess to create a global low Earth orbit constellation of ultimately some 12,000 satellites that would provide broadband, sort of 100 megabit, gigabit connection speeds to every single person on the planet, every square meter on Earth. Mm-hmm. And that's a huge, huge potential. So that's Elon. It has been launch vehicle focused, and then communications focused, and then ultimately saving the human race focused. Mm-hmm. And he's dead serious about that. I mean, I've had long conversations where he's like, I have to completely rework what SpaceX is building because it's not going to meet our Mars objectives. Bezos, on the other hand, Jeff's done this differently. He has basically built Amazon as a means for his personal cash flow, and then he's personally funding the development of his launch vehicles, the New Shepard and the New Glenn, which are named after Alan Shepard and John Glenn. And then most recently has started looking at, can he fly people into space and can he get government contracts? And both Jeff and Elon, in the near term, given the Trump administration's focus on the moon, are really focused on, can we get large payloads, like multiple tons, 3 to 6 tons per lander, and people onto the lunar surface, and can we do that in the next 5 years? So That's where there's similarity. Both of them are building launch vehicles. Both of them are building reusable launch systems. They can come back to the Earth and refuel and go again and going to the moon. But in the long term, Elon wants to go to Mars, and Jeff wants to build what are called O'Neill colonies. And Gerard K. O'Neill was one of my mentors, was a professor for Jeff while he was at Princeton. And he said, why would you ever want to go and land back on a planetary surface and have to claw your way out of the gravity fields again to get back into free space? Why don't you instead create beautiful colonies in space, large million-person colonies that would rotate slowly and create artificial gravity, and you could place them, near the Earth so that the commute time is hours, not, a year. So,
sort of the space version of floating cities.
Yeah, exactly. The space version of floating cities.
Yeah, the
exactly
space
right.
version. And one of the things that struck me is that really the first 20 miles is the most formidable barrier from a cost standpoint. It just costs a lot to take a pound of anything.
And I'll correct that slightly by saying it's sort of the first 60 to 100 miles, but you're right. So when you go into Earth orbit, where Earth's atmosphere ends and where space begins, very interesting story there. So it turns out that a country owns your airspace, but doesn't own the space over your head. So if there's a Russian or Chinese fighter jet flying through U.S. airspace, you can say, get out or we'll shoot you down. If there's a spy satellite flying over the U.S., you can't do anything about it. And so airspace was always loosely defined. In 1957, October 4th, 1957, when the Soviets launched Sputnik, there is a policy conversation like that happens where this Sputnik vehicle, the Sputnik satellite is flying over the United States, and it's like, first of all, you couldn't shoot it down in 1957, so you could do anything about it, but do we tell them you can't do that? And, the U.S. government, I'll call it its wisdom, whatever, said no, because we want to be able to fly satellites over Russia too. So interesting definition, and it was always left vague where space begins. And the U.S. Air Force defined it as 50 miles. The Europeans defined it as 100 kilometers, and others defined it as 100 miles. For the purpose of the Ansari X Prize, where people had to build a private spaceship and carry 3 adults twice into space, we used the 100 kilometers definition, 62.5 miles. Yeah. But you're right, getting into space is the hard part, getting into orbit. To be in orbit around the Earth requires a certain amount of energy, velocity, to counter, so centripetal force countering gravitational pull. And you have to be outside the atmosphere, otherwise the drag from the atmosphere will slow you down and you'll re-enter quickly. So the lowest satellites are typically around 60 to 100 miles. Like the space station is, somewhere in the 100 to 200 miles, I forget exactly, altitude. And you have to boost it because while you're in space, there's still molecules of Earth's atmosphere even up there, and they slow you down over time. But you're right, it's hard.
NASA, probably the most spectacular successes that they've had, which have, impacted on the public, has been the rovers. And these are robots that they've sent to Mars, and it's been a spectacular success. They seem to have been really great with their robot vehicles. And from the standpoint of robot-human teamwork, when you're talking about the moon, going back to the moon or going to Mars for the first time, what do you see the phases there? Because probably the existence of water and oxygen that can come from water is a fundamental development threshold that you have to cross, that you can't take the water with you, you can't take the oxygen with you, and be there for any length of time. So what have you seen as the real progress with the robot rover, especially, Mars, it's been mostly Mars, but in the moon now, they've got photography that has identified water deposits on the moon.
Yeah, interesting. You're spot on, Dan. It turns out that, if you look at the moon, it's barren, it's got no atmosphere. Any water that is in the form of ice or anything on the surface of the moon would instantly sublimate, goes from solid to gaseous form, and the moon's gravity is so low that it doesn't contain it. It drifts onto space. But what they found was that on the north and south pole of the moon, there are what they're called permanently shadowed craters. And these are craters that never see sunlight. people think that the moon does not rotate. It does. It rotates in sync with the Earth. It's in a gravitational lock, so it rotates once every moon orbit. So every part of the moon sees sun, except for these deeply shadowed parts of the pole. I don't know if you know this, but every ounce of water, or I should say every liter of water on the Earth's surface, actually came from comet and asteroid impacts. So when you drink a glass of water, the water molecules here originated from space, because when the Earth was formed in its earliest phase in this molten lava rock, there was no water there. It had been vaporized before there was an atmosphere and escaped. And then as the Earth cooled, it was in a period of bombardment where the Earth was bombarded by asteroids and comets. And then all of this early stuff was ice, and it just filled the oceans and the rivers and the lakes and all this stuff. So same thing happened on the moon, but when a comet hit the moon's surface and it splattered little bits of ice that fell into the permanently shadowed craters, never sublimated. It stayed. Everything else sublimated and went from ice to gas and escaped the moon. And so we found that, this is within the last really 10 years that it was all confirmed, and that becomes a place where we're going to go and mine water. The Earth's regolith, which is, if you would, the dust, the sand, the equivalent of Earth on the moon, it's called regolith, is made of iron and aluminum and nickel, which are construction materials, and oxides, and silicon for solar cells. So you're going to be able to build stuff. So I think we'll see humans go back first just because it's what we humans do, but we'll leave behind construction robots. The time delay, the round trip time from the Earth to the moon and back is only 2.4 seconds. So you don't have to have full autonomy. You can do stuff with a delay. Mm-hmm. And this is a lot of the work that this guy, Gerard O'Neill at Princeton, did. He figured out how you would go and mine the moon and how you would go and operate autonomously and robotically on the moon. So we'll do that. Mars is more difficult because you've got, significant time delay, and it takes a long time to get there.
Mm-hmm. One last thing, because we're both passionate about medicine, especially age extension medicine. What do they know now about humans not being in their natural environment? In other words, you're not in atmosphere which protects us from solar energy, and we're weightless, and weightlessness really affects the human body. And one of the things I had never thought about, but one of the big effects of living in gravity-free is what happens to your eyeballs, because your eyeballs are the shape they are, and they work perfectly simply because of the gravitational system, and that when you free the eyeballs up from gravity, they start to change shape.
A lot has been learned over the years. In fact, I did, when I was at MIT and in medical school, I ended up doing a lot of my work on the transformation of the human body in space. And so a lot happens. Our bodies are actually designed to be fighting against 1G and be active and to constantly see. And so everything from the fact that your bones get weak, your bones are dynamic parts of your body. If you are skiing, the stress points of your bones gain in strength. If you're bed rest for 6 months, your bones become fragile. So being in space is like being in bed rest. And so there are drugs that you can give to stop these osteoclasts, which break down the bones. You can do that. People do exercise on bungee cords against treadmills to try and get that push. But your heart also becomes weak. It doesn't have to push against a gravity gradient. You see water moving from the lower parts of your body cephalically towards your head, and your kidney sees this as having too much fluid on board, so you end up peeing away a good amount of volume. And then we're starting to see the fact that living in space, especially above the Van Allen belts, will lead to a large increase in radiation. So we're seeing increases potentially in cancer. And even at the cellular level, I remember when I was at MIT, I remember this guy, Professor Kogoli, did some work that showed that macrophages and T cells, their functionality is a function of the gravity level. Like more gravity meant they were able to chomp on bacteria and bugs faster and better. We're going to have to figure that out. Will we put rotating space colonies, which is what O'Neill said will create the gravity, by just rotating you at the right rate so you have 1G on the inside. And by the way, as you get older, why don't you move to a half gravity part of the space station?
Yeah, it's easier for you.
Yeah, and if you want to go put on a pair of wings, You could go and fly in the zero gravity part of the space station. The moon at 1.6G is going to be fascinating. It turns out that there are these lava caves in the moon, large, if you would, volumes that you could potentially seal if you find the leaks and you seal them, and you could fill them with oxygen, and you can create underground caverns that are filled that you could live in. But I think one of the coolest things I ever saw was a design for putting on a pair of human wings, and your strength is enough that you could fly like a bird in 1.6G if you had 1 atmosphere of atmospheric density. So a lot of cool things to be had, but yes, the body has to be carefully measured to make sure that you don't end up losing your health. But we will evolve.
Yeah.
We will evolve into new species.
Yeah.
It will speciate for sure.
You know, I'm strictly a spectator here. I remember once you said, Dan, do you have any desire to go into space? And I said, lots of oxygen there. And you said, no. I said, that's a downer. What about gravity? I said, I know gravity ultimately wins, you know, talking about our longevity. We're in a tussle with gravity our entire lives. And I do my best to not give death assistance here. But, you know, I'm fascinated with it from a standpoint of just humans creating what I call free zone frontiers. It's where something is underused, something's underdeveloped, and someone pushes out and creates new territory in a completely different realm. And this is very entrepreneurially. So
It is. I think about it the following way. 2 or 3 important points to mention on what you just said. Number one, it used to be that if you screwed up, you could go to the frontier and start again.
Mm-hmm.
Really hard to do that these days. So really hard to start again. And the frontier, it didn't matter what color your skin was, how old you were, whether you're male or female. If you were the best person to do something, people came to you. It was full up of meritocracy. So those are 2 important things. A third is that there's no place we can really go and experiment with new forms of government. It's sort of hard to go. You have to overthrow a country and then convince all of its citizens to try something different. But space may be a place that we can start new forms of government.
doing experiments.
Experiments.
Yeah.
The last thing I'll just mention is that everything we hold of value on Earth, metals, minerals, energy, real estate, are near infinite quantities in space. A lot of wealth to be created out there.
Yeah, and you were a pioneer in creating ownership laws in outer space. I remember, when was that, 7, 8 years ago, that certainly the Congress of the U.S. voted and said, you know, if you're exploring outside of Earth real estate, ownership rules actually work. And a lot of people will say, well, you know, that's so far off. And I said, it's absolutely crucial that private ownership actually makes the jump from Earth out into outer space, or you're not going to get any economic development.
Yeah, you and I on a previous podcast, I think it was on construction, were talking about the idea that the land grants for the railroads, right? It turns out you and I were researching them at the same time for different reasons.
Yeah. Yeah.
Right.
Yeah. Well, my feeling is that the United States is basically a free zone frontier that was built out of the combination of free land and free people. That's what actually created it, you know, that if you were willing to take the risk, you know, and it was quite an arduous challenge in those days, but the typical land grant was 640 acres. And the rule was that if you improved those 640 acres, it was a square mile, 640 acres, and you improved it, and namely you put buildings on it and you raise crops on it, it was yours. And a lot of people don't realize, I mean, it was taken from Indians. Certainly there was no question that Native Indians, the territories got, but they never had a concept of ownership, so it wasn't. But the vast majority of the U.S. was purchased from France or from Russia or from Spain, and it was actually purchased. Louisiana purchased to this day is the greatest real estate purchase, 17 states for $10 million, and even in upgrading it from 1803 to 2019, it's still 50 cents an acre in 2019.
Wow.
Because I think it's 33 million acres, and it was done with a handshake because Napoleon knew if he didn't sell it to us that the Americans would just take it. So he said, I might as well get some money.
I'll take the cash.
Because I can't defend it. But the whole point is that when you take things that are kind of competition free, and they're just there to be developed, and you can combine them. One thing I'd like to ask you, because you're really big on convergence. If you look at the three convergences that have to happen, we can wrap this up, but three convergences that are not fully real yet, but three things happen. What are the three most important things for the space exploration to speed up significantly right now?
So, great question. And there's a number of them. When we go to the moon, we're going to put AI-driven robots and 3D printers that are going to build our stuff for us. This will be true on Mars as well. The real true breakthroughs are going to come from material sciences, new materials that are stronger, more capable, lighter. The ultimate breakthrough that's going to drive space is nanotechnology, where you can manufacture materials, atoms at a time, molecules at a time. You could create a diamondoid engine where it's, super thin, but it's made of the strongest material out there. And, other types of convergences that we'll see is genetically engineering life forms to live under different conditions of atmospheric conditions, radiation conditions, gravity conditions, and so forth. So all these things are going to be happening, but it's fundamentally all comes down initially to the price of launch. The cheaper you can get things, the more reliable you can get things. That's why the breakthroughs that Musk and Bezos have been driving in terms of reusing the vehicle instead of throwing it away is the biggest deal. And then it's scale. I don't know that physics will ever teach us how to shield gravity. That would be great. I'd love warp drive. I'd love gravity shielding. I've been living too long in the Star Trek world. But ultimately, I like to say the most important thing for space is creating an economic engine that drives us there instead of being dependent on the government, which has been the last 50 years.
Yeah. One of the things I want to, for my contribution to this is probably the most influential books, in the last 50, 60 years regarding science was Thomas Kuhn's Structure of Scientific Revolutions. And he said, a lot of people don't realize this, but the single factor that causes the biggest breakthroughs in science are actually funerals.
Oh, okay. Just because the old farts die.
Older scientists die, older engineers die, and there's room now for an entirely new category. He says you'd be surprised how much older scientists control what new things can be created because of prestige.
100%.
Yeah. And so, we just have to have enough funerals for the real innovators to break free.
Yeah, it's funny, right? If you're the world's expert in something and someone comes along with a completely disruptive approach, then you're not the world's expert anymore in the cutting edge thing.
And you'll stop the competition. Yeah.
Crazy.
So interestingly, humans at the age of your two boys don't see the problems for this. They just see the opportunity.
Yeah. And then one of the things I think about, and I'll close on this perhaps, is physical frontiers have always been sort of the awe-inspiring part of our lives. And, for my two boys that are just turning 8, I think about the fact that it's going to be digital frontiers that are far more exciting and far more inspiring and have infinite life forms and infinite potential and cost zero time and zero money to get there. So it'll be interesting to see whether realistic virtual worlds put a kibosh on some of the exploration that humans do.
These challenges really change. I said I was going to say a last thing, but I just want to compare. It was May of 1953, and I remember the news came through that Sir Edmund Hillary had ascended Everest. He had gotten to the top. And my morning newspaper, the Toronto newspaper that I still read, they showed a queue of 320 people waiting in line to get to the top of Everest, and 11 of them died.
Today, this year.
This is 2 days ago. 320 people were queued up to get to the top of Everest. And while waiting, 11 of them died.
Wow.
And they're saying, this is no longer a frontier challenge because they have about a 3-week window in May every year when ascents could be made. And now they're lining up. People are waiting in line for 5-6 hours, using up oxygen and everything else, waiting in line so that they can get actually to the ascent. I said, it's not as much a challenge as it was in 1953. And so new challenges have to be created.
Incredible.
Yeah.
Well, as always, Dan, I love my time with you. Thank you.
Thank you, Peter.
Take care. See you next time.
Okay.